Hi, grade 8 students. I hope you are all doing good. In this video, we're going to solve together worksheet 2B in our lesson square roots. Number one, we should simplify the following square roots. Let me tell you something very important here that you should never forget. Whenever you are simplifying a number inside the square root or inside the radical, this number should be written as a square number, since the square cancels the radical, so the number can come outside as it is. Now, let me start. Radical 11 squared. We say the squared cancels the radical, so I will get 11. Radical 21, all of it squared, also the squared cancels the radical, and the answer is 21. Radical negative 13, all of it squared. Let me tell you something about this. This is a negative base. All the negative 13 has an exponent 2, which is an even exponent. And we know that a negative base having an even exponent, it changes into positive. Then we say the square cancels the radical, and the answer is 13. Radical 6 squared, also the squared cancels the radical, and the answer is 6. Radical negative 6 squared. Is negative 6 a negative base? Of course, no, since it's not written between parentheses, so the square is only given for the 6. It has nothing to do with the negative, so our answer inside will be negative, and we know that a negative radicand, of course, it does not exist. Radical negative 9, of course, negative 9 is a negative radicand, and a negative radicand does not exist. Negative radical 23 squared. Here, the negative is outside the radical. It has nothing to do with the radical. So it stays a negative, and we say the squared cancels the radical, so our answer is 23. Now we have radical 25 over 36. If you can see, 25 over 36 is a fraction. So our answer, the root of this fraction, is also a fraction. If you look at radical 25, can we write it as a perfect squared? Yes, it's written as 5 squared, and 36 can be written as 6 squared. So we write them as perfect squared. Now the 5 squared comes outside as 5, and 6 squared comes outside as 6. So our answer is 5 over 6, not 5 times 6. Now we continue. We say now we have negative radical negative 2, all of it squared. As I said, a negative base to the exponent 2, it becomes positive. The negative here outside, it stays as negative, and the squared cancels the radical, so our answer is 2. Radical 64, please always ask about the number inside the radical. If it's not written as a square as the examples we were solving, we should ask, before making the prime factorization, we should ask, can we write this number as a perfect squared? Yes, 64, it can be written as radical 8 squared. It has nothing, no need to do the prime factorization for the number 64. Now the squared cancels the radical, and the answer is 8. Radical 100, also 100 can be written as a perfect squared. It's radical 10 squared. The squared cancels the radical. It comes out as 10. Now, radical 120. 120 cannot be written as a perfect squared, so we should do the prime factorization. This is the prime factorization of 120. I should write each 2 times 2, we write it as 2 squared. We have 1, 2, so we keep it 2 squared times 2. We have 1, 3, so it's times 3. We have 1, 5, so it's times 5. These are the prime factors of 120. Now, these prime factors, we replace them inside the radical. So we write radical 2 squared times 2 times 3 times 5. The only number inside the radical, which is 2 squared, can come outside the radical. Here, it has an exponent 1. It stays inside the radical. 3 stays inside, and 5 stays inside. So 2 squared comes out as 2. So we write 2 radical 2 times 3 times 5. Don't leave it like this. Multiply the numbers inside the radical. If we multiply 2 times 3 is 6, times 5 is 30. So our answer is 2 radical 30. This is the simplified radical 120. Now 1024, radical 1024. Let's make the prime factorization of 1024. This is the prime factorization of 1024. So to write the prime factors, we take each 2's together. 2 times 2 is 2 squared, 2 squared times 2 squared times 2 squared times 2 squared. So these are the prime factors of 1024. We replace them inside the radical. Now, this 2 squared comes outside as 2. Each 2 squared comes out as 2. So this is the answer. If we multiply them, so the answer is 32. So 1024, as you can see, it can be written as a perfect squared. It's 32 squared. Now let's perform or calculate addition of radicals. The rule of addition says we can only add or subtract radicals having the same radicands. So we should make sure before addition and subtraction that the radicands are the same. This is number one. Number two, how can we add or subtract? We add or subtract the coefficients, the numbers before the radicals, then we keep the radicand as it is. So 6 radical 3 plus 2 radical 3. Since we have the same radicands, the coefficient is 6 plus the coefficient 2, it's 8, and we keep it radical 3, so it's 8 radical 3. 3 radical 5 plus radical 5. Any radical without a coefficient, you should know that the coefficient is 1. It's not 0, since 1 is the only coefficient that I can write it or cannot write it. So 3 plus 1 is 4, and we keep radical 5 as it is. Now 2 radical 11 plus 4 radical 11 plus radical 11. Same radicands, so we add 2 plus 4 is 6 plus 1, so it's 7 radical 11. 11 radical 6 minus 4 radical 6, same radicands, so we say 11 minus 4, it's 7 radical 6. 2 radical 7 minus 9 radical 7. 2 minus 9, since 9 negative, it's degraded, so it's negative 7, and we keep radical 7 as it is. Negative 5 radical 2 minus 7 radical 2. Two negative numbers added together, negative 5 and negative 7 give negative 12, and we keep radical 2 as it is. Negative radical 10 minus 8 radical 10, so as if it's minus 1, minus 8, minus 9 radical 10. Now minus 7 radical 13 plus 12 radical 13, minus 7 plus 12 is 5, and we keep radical 13 as it is. Now we have 14 radical 15 minus 5 radical 15 minus 3 radical 13 minus 6 radical 13. We cannot add radical 15 with radical 13. We can add radical 15 with radical 15, so we take the first two radicals. 14 minus 5 is 9, and we keep radical 15 as it is, so it's 9 radical 15 minus 3 radical 13 minus 6 radical 13. We do them together. Minus 3 minus 6 is minus 9 radical 13. 3 plus 2 radical 7. We are adding a number with a radical. We cannot add a number with a radical since they are different. So since they are different, we keep the answer as it is. So it's 3 plus 2 radical 7 cannot be added together. 5 radical 3 minus 9, different, a radical different from a number, so the answer stays as it is. 2 radical 21 plus 3 radical 5, we have different radicands, so they are different, we keep the answer as it is. Radical 6 minus 5 radical 7, also different radicands, so we keep the answer as it is. 3 radical 10 minus 6 radical 3 minus 8 radical 10. We cannot add radical 10 with radical 3, so we add 3 radical 10 minus 8 radical 10. It's minus 5 radical 10 minus 6 radical 3. We keep it as it is, and this is the answer. We cannot add radical 10 with radical 3. This exercise is very important. Please correct it and understand it well. Now we have this expression, 2 radical 2 minus 5 radical 8 plus 7 radical 50. We are adding different radicands, radical 2 with radical 8 with radical 50. Of course, we cannot add them when they are written like this. We look inside the radical. 2 is a prime number, we keep it as it is. 8 is a composite number, so we should change it to a prime number using prime factorization. 50, we change it to prime factors using prime factorization. This is the prime factorization of 8, so we write 8 equal to squared times 2. 50, this is the prime factorization of 50. It's written 2 times 5 squared. Now the prime factors of 8 and the 20 and 50, this is 50, of course. This is a typing mistake. So the prime factors, now we write them inside the radicals. So we keep 2 radical 2 as it is, minus 5 radical. Instead of 8, we replace it 2 squared times 2, and plus 7 instead of radical 50, we replace it by 2 times 5 squared. Now, 2 squared comes out as 2. Since we have 5 as a coefficient, so we multiply 5 times 2. 5 squared comes out as 5. We multiply 7 times 5. Now, we have to multiply. Now, all the radicands are the same. So 2 minus 10 is minus 8 plus 35. Our answer is 27 radical 2. We can add or subtract since we have the same radicands. Another expression, 4 radical 24 minus 7 radical 96 plus radical 54. We should make 3 prime factorizations. For the number 24, these are the prime factorizations. The number 96, these are the prime factorizations. And the number 54, these are the prime factorizations. Now we replace each prime factorization inside its radical. Then we simplify, we multiply, and now we have the same radicands. We can add or subtract the coefficients. So our answer is negative 17 radical 6. Another example. I will not solve this example since I solved 2 examples before. So we replace the prime factors and we get our answer. Also, this example is solved for you here. Also, we replace the prime factors inside the radicals and we get our answers. These examples are very, very, very important for you to solve. Now, multiplication of square roots. The rule of multiplication, we have 3 rules for multiplication. If we are multiplying a number by a radical, a times radical b is a radical b. Radical a times radical b is radical, and we multiply a times b. Radical a times radical a, it's radical a squared, and the answer is a. Now we have 5 radical 2 plus 2 radical 3. Here we have radical 2 and radical 3, different radicals. We multiply the coefficient by the coefficient and the radical by the radical. 5 times 2 is 10, so it's 10 radical 6. Now we have 3 times 9 radical 7. We are multiplying a number by a radical. So we multiply the number by the coefficient and we keep the radical as it is. 3 times 9 is 27 and we keep radical 7 as it is. Now we have minus radical 11 times 4 radical 5. Also, 2 different radicals, we multiply the coefficients. Negative 1 times 4 is negative 4 radical 55. Negative 7 radical 6 times negative 3, we multiply a radical by a number. Negative times negative is positive. 7 times 3 is 21, and we keep radical 6 as it is. Now radical 3 times radical 3, radical a times radical a, all of it squared, which is equal to a. You should write radical 3, all of it squared. Now the squared cancels the radical and the answer is 3. The same here, we multiply the coefficients. 2 times 5 is 10. Radical 13 times radical 13 is radical 13 squared. Now the squared cancels the radical, so it comes out as 13. 10 times 13 is equal to 130. I told you last lecture a very important rule, which is when you have a radical and inside the radical you have a plus or a minus, this radical cannot be split. So we cannot write radical 9 plus radical 6. We should add the numbers inside the radical. So the answer is radical 15. Radical 25 minus 9, it's radical 16. Now our answer should be always simplified. 16 can be written as a perfect squared. It's radical 4 squared, and the answer is 4. Now radical 6 squared minus 3 squared, this cannot come outside the radical since we have a minus here. So 6 squared is 36 minus 3 squared, which is 9. Radical 36 minus 9, it's radical 27. 27 can be simplified. We make the prime factorization. It is radical 3 squared times 3. 3 squared comes out as a 3, so our answer is 3 radical 3. Now radical 7 squared minus radical 5 squared. Radical 7 squared can come out since the minus is not inside the radical, it's outside the radical. This is the difference between this and this. Here we cannot get them outside since the minus is inside the radical. So radical 7 squared is written as 7 minus radical 5 squared is written as 5, and 7 minus 5, of course, it's 2. Also, these rules are very important. Please correct your mistakes. And after watching this video and correcting your mistakes, if you have any question, please contact me directly. Bye.